organic compounds known to us. And many new organic compounds are discovered every year in nature or are synthesized in laboratory. In the early days, chemists recognized that compound is having similar structural features, have identical chemical properties. For this, they began to classify compounds based on the common structural arrangements found among them. Today, we will learn about them. Let's start with me, Bindu. Before starting, let's revisit the previous session once again. Carbon forms a large variety of compounds. Valency of carbon is 4. Methane molecule is sp3 hybridized. So, it has tetrahedral structure. Ethylene molecule is sp2 hybridized. Acetylene molecule is sp3 hybridized. Learning outcomes. At the end of this session, you will be able to understand about different types of hydrocarbons, functional group, rules of organic nomenclature, examples of nomenclature of organic compound. Keywords are saturated hydrocarbon. The hydrocarbons containing only carbon-carbon single bonds. Unsaturated hydrocarbon. The hydrocarbons containing at least one double bond or one triple bond between the two carbon atoms. Functional group. An atom or group of atoms in a molecule. Homologous series. A group or a class of organic compounds having same general formula and similar chemical properties differ by only a CH2 group. Nomenclature. Naming of a compound. Before starting the session, let's look at the concept map. Our first topic is different types of hydrocarbons. Saturated and unsaturated hydrocarbons. The hydrocarbons containing only carbon-carbon single bonds are known as saturated hydrocarbons. All alkenes are saturated hydrocarbons. The hydrocarbons that contain at least one double bond or contain at least one triple bond between the two carbon atoms are called unsaturated hydrocarbons. Alkenes and alkynes are the examples for unsaturated hydrocarbons. Open and closed chain hydrocarbons. In the example on screen, you will notice that all carbons are linked to one another, resulting in a linear structure. In this example, 4 carbons are linked in a linear way and the 5th carbon is linked to the parent chain resulting in a branch. Here, we find that carbon chain is closed to form a ring. So, it is a closed chain hydrocarbon or ring hydrocarbon. Functional groups. A functional group is an atom or group of atoms in a molecule which gives its characteristic chemical properties. The chemical properties of an organic compound depend on its functional group, whereas its physical properties rely on the remaining part of the structure. The compounds containing C, H, X, where X represents halogens, Cl, Br, I atoms. These are known as halogen derivatives of hydrocarbons or halohydrocarbons. The hydrocarbons that contain OH group are called alcohols. The hydrocarbons with functional group CHO are called aldehydes. The hydrocarbons with this functional group are called ketones. These are the examples. The general molecular formula of carboxylic acid is RCOOH, where R is an alkyl group or H atom. Ethers are carbon compounds related to H2O in such a way that both hydrogen atoms are replaced by two alkyl groups which may be same or different. These compounds are derivatives of carboxylic acids. If the hydrogen atom of COOH gets replaced by R, the alkyl group esters are obtained. If hydrogen atom is replaced from NH3 by an alkyl group, they are called amines. NH2 group is called amine group. Children, you can check all of the functional groups here. Let's consider the series on screen. You can notice that each successive member has one methylene group more than the precedent member of the series, and hence they are called homologues. Homologous series is a group or a class of organic compounds having same general formula and similar chemical properties in which the successive members differ by a CH2 group. The IUPAC name of any organic compound consists of three parts: root word, prefix and suffix. These parts are combined as per the sequence appeared on screen to get the IUPAC name of the compound. Root word. It is the basic unit which describes the carbon skeleton. It gives the number of carbon atoms present in the parent chain of the compound and the pattern of their arrangement. Prefix. The prefix represents the substituents or branch present in the parent chain. Suffix. The suffix forms the end of the name. It is divided into two parts such as primary suffix and secondary suffix. The primary suffix comes after the root word. It represents the nature in carbon to carbon bonding of the parent chain. If all the bonds between the carbon atoms of the parent chain are single, then suffix "-ane" has to be used. Suffix "-ane" and "-ine" are used for the compounds containing double and triple bonds respectively. The secondary suffix describes the functional group of the compound. Rule 1. Identify the longest chain of carbon atoms to get the parent name, root word. Rule 2. Number the carbon atoms of the parent chain, beginning at the closest end of the substituent or functional group. These are called locant numbers. If both functional group and substituent are present, then the priority will be given to the functional group. Rule 3. In case of alkenes and alkynes, locate the double bond or triple bond and use its locant number followed by a dash and a primary suffix. The carbon chain is numbered in such a way that the multiple bonds have the lowest possible locant number. Rule 4. If the compound contains functional group, locate it and use its locant number followed by a dash and a secondary suffix. Rule 5. When the primary and secondary suffixes are joined, the terminal E of the primary suffix is removed. Rule 6. Identify the substituent and use a number followed by a dash and a prefix to specify its location and identify. We shall learn nomenclature by solving this example. Step 1. The longest chain contains 7 carbon atoms and hence the root word is hept. Step 2. There is a substituent. So, the carbon chain is numbered from the end, which is closest to substituent. Step 3. All are single bonds between the carbon atoms and thus the suffix is "-ane". Step 4. The substituent is a methyl group and it is located at third carbon. So, its locant number is 3. Thus, the prefix is 3-methyl. Hence, the name of the compound is 3-methyl heptane.